We'll be starting this session in just 9 minutes. Yes, we'll be starting this live session in 6 minutes, right? So, today's topic is about linked list. I'll tell you what is a linked list and then we'll be solving some problems, right? Okay. Yes, in 5 minutes we'll be starting this linked list, right? Yes, today's topic is linked list, and we have covered like arrays, hash map, sliding window, prefix sum, and then binary search. Then now it's time for linked list. Let us write that in an order. Why not? Arrays, arrays, and then hash map, and then sliding window, and then we have solved about binary search. Right? Is there anything that we have missed? Let me check. First, we have solved arrays, and then we have solved about hash map, and then sliding window, and then binary search. But before this binary search, we have solved prefix sum. So after sliding window, we have solved prefix sum. I think my writing is clear for you. So anyone who are watching, Namib, hi, bro. Yes, thank you for watching this live session. So we'll be starting this in 4 minutes. Okay, we started with arrays and then hash map and then sliding window and then prefix sum and then binary search, binary search, and then today it is about linked list. Okay, it's clear for you. Yes, okay. First, we'll be waiting for 3 more minutes, right? So let us see that what's the subscriber count. I think it's 812. Okay. I have recently uploaded a shorts, right? Like 3 to 4. I don't know the exact count, but I think you have solved, those who are watching this live, you have solved that today's lead code PODD, right? So it's day 381. The streak for me, my daily streak is 381 days. So let me reset it. But anyway, this is today's lead code POTD problem of the day. I have uploaded the video explanation in my YouTube channel, this channel itself, right? Go and check it if you haven't solved it. So let's come up with the linked list, right? Let us see what trains will be. Let us see what a trains will be. How does these trains look like? There is a connection between the trains and the linked list, right? Okay. If you see these trains, they are connected one with another, right? So you might be wondering, this boy is saying like linked list and then opened these train images. But let me tell you what it looked like, right? So if you see this, if you see, let us take this copy image. Let me paste that image here. Okay, crop. How can we crop this image? Right? Okay, I think it's okay. But duplicate, delete, group selection, no. Okay, let it be. Okay. Okay. We have this train, right? We'll be waiting for 1 minute, but I got this train now. Can we flip this? Flip horizontal. Okay. Now, let me tell you what does the train will be having. Let me tell you, right? So first, what does this train have? At this point, at this point, let me name this. Let me name this the one here. I think is highlighted, right? It is not highlighting it. Okay, this one. Let me name this as head, right? The engine is named as head. That's what I am saying. The engine is named as head. That's it. Now, if you see, there is a connection here. There is a connection. I think you all agree with this. I'm saying that there is a connection from this engine to another one, right? So the next one. So in Telugu we will be calling this as a bogie, but I don't know what it will be called. Or we can say that as a compartment, right? So the next compartment. This head is connected to head is connected to next compartment. Next compartment. Let me tell you what is this next compartment and why we are taking this into our linked list live session. So there is a connection, right? Let me take that connection in black color. It's not visible. So let me take it in blue. So there is a connection. Now there is another connection and let me name this one as the tail. Now, if you see, engine is named as head or it is called as head by me and head is connected to the next compartment. Let us just take those things which are important to us, head and then next, and here it is tail. Now, every compartment is connected to the next compartment. Let me tell you, this head, this head, right? This head compartment is connected to the next compartment, and this is connected to the next compartment, and this to the next compartment. If you see, X mark on last of train, X mark on last of train. On back, I think it should be better if I type as back. So X mark, if you see, there is this X mark every on every train, right? So let us learn from these trains our linked list. So I am placing an X mark on the last compartment. So what does this X mark mean? Let me know in the comments. What does this X mark mean at the last, right? So if you see, there is no next compartment to the last compartment, right? So if I am saying this, there is no next compartment to the last compartment, which is X. Let us write this again in our linked list order. Now, this is called as a node, right? And this is nothing but pointer, next pointer pointing to pointing to the next node, right? Now, this will also have a next pointer, but it will be pointing to the next pointer pointing to next pointer will be pointing to will be pointing to null pointer. That's the difference of the middle ones and the last one, right? Now, we are saying that it is pointing to the next node. What does this mean? So, if I say 0x11, 0x12, 0x13, 0x14, now next of head, this will store 0x12. This will store in next here. It will be next here. So here it will store 0x13. Here it will store 0x14. Here it will store null. So that's why I said this is our last node. Now let me be clear that if you have understood this or not, right? So if you are having any doubts, please let me know in the chat box, right? So we have introduced about the linked list just now. We got a clear introduction about linked list. Please let me know in the chat box. So if you are having any doubts or want to give me any suggestions about these live sessions and this course, we'll be having like 30 days, but this is our day 6, right? So we have covered with arrays first. We have covered with arrays on day 1, hash map on day 2, sliding window on day 3, prefix sum on day 4, binary search on day 5. Now today it is day 6, right? So yes sir, clear. So we'll be going to the next problem. Thanks for commenting, bro. Namib. So no need to call me that. I am not a sir. I am just in my 4th year of BTech. So you can call me bro, right? Okay. So we have just cleared about using these trains. We have understood what does this linked list actually is. Now let us see that as we are learning in Java, let us see how can we uh, go with the problems. First, let us look at the first problem for today. Linked list cycle. Let me tell you, that a person around a globe. Let us take around a globe. A person A there are points like this: 1, 2, 3, 4, 5, 6, 7. We'll solve that linked list cycle. But before that, let me know that I got A here. I started B is starting here. Now, let me be clear with my question. Will they meet? Will they meet? I want the answer in the chat box. If they go in the cycle, will they meet? Now, you might say that they will meet. They will meet if A is going only one step, but B is there itself, so they will be meeting. No, not like that. A and also B both will move. I will not tell you whether they move one step forward or two steps forward or three steps forward. No, I don't tell you, but will they meet? That's my question. That's my question for you. So, Will they meet if they both move, right? If they both move, will they meet in around the globe, right? So these are some of the points. Point 1, 2, 3, 4, 5, 6, and then 7. Will they meet? Let me know in the chat box. I'll give you just 1 minute of time. Will they meet if they both move? So even if it is wrong, don't hesitate. There is no one like a judge to give you any score, or it is not any contest, right? Okay. Will they meet if A and B both moves in clockwise direction? They both move in the clockwise direction, but it is not that B will be at the same point and A will be at the same point. No, no, not like that. They both will move, but will they meet? Yes, they meet, but not sure. Okay, so let me tell you, but why it is like will they meet or not? Let me tell you that if A is starting at point 1, 2, 3, 4, 5, 6, and then 7. Now, B is starting at 2. So, if A and B both moves with a speed of 1, then they will not meet, right? A will go to 2 and B will go to 3, and A will go to 3 and B will go to 4, and A will go to 4 and then B will go to 5. So they will not meet. They will be coming to the same point, A, B, like this, A and then B like this. So there will be no something like a meeting position. I'm saying that this is a globe. Why? Because globe is a cycle, right? Now, what if I say that A moves 1 point, but B moves 2 points? Let me tell you, A has started initially here A, and initially here B. So A started here, B started here. A moves A moves 1 point, B moves, okay, I think you all got understood it, but let me explain. A moves 1 point, now A moved 1 point and B moves 2 points. B was at here, now it is coming here. Now A moves 1 point, previously our B was here. Now B moves 2 points, okay, here is our B. It was our A here, it was our B here. Now I'll move my A here and I'll move my B here, right? So A is here and then B is here. Now let me move A for 1 point and then B is here. Now let me move my A for 1 point, A for 1 point. Previously our B was here. So if I move my B for here 2 points, then it will be here. Now I will move A for 1 point and B for 2 points. So our B was here, and A was here. A is here. Now if I change from here to here 2 points, then our A and B will definitely meet. If A moves 1 point, B moves 2 points. That's it, right? So there will be definitely a cycle if A and B meets. That's it, right? Now you might say that, bro, you'll be having like a linked list like this. Now, will they meet? No, definitely no. Why? Because A will be here and then B will be here. Then A will be here, B will be here, and then A will be here, B will be at null pointer. Why? Because this to the next and the next is null pointer, however. So we need to write an algorithm for this. But let me tell you that A moves 1 pointer. A will be at head and B will be at head next. Right? I might get any error in middle, but let us go with the with it. Now, why? A is not equal to null pointer and also B is not equal to null pointer. Now what I said, A moves one step ahead. So A is equal to A next and B is equal to B next. There is a problem here. I'll tell you what it is. B next and then next. Next and then next. Okay. So there will be a problem. I'll tell you what is the problem here. Now, if A and B is equal, if A and B are equal, if A is equal to B, then return true. There is a cycle. If after this it doesn't got, then return false at the end, right? Bro, explain null pointer mm, means for a time. Bro, explain null pointer for a time. I didn't understand what it means. Menas. Okay, it might be a typo, I think, a spelling mistake, but let me know that. What does a null pointer mean? That's what you are asking, Nami Pro, right? What does a null pointer mean? Is that what you are asking? What does a null pointer mean, right? I think that's what you are asking. So let me know if what is null pointer. Okay. So null pointer is, I'll tell you, right? I'm saying that I have a linked list like this. I have a linked list like this. Now, there will be next for every node. There will be a next for every node. This will also have a next. I'll tell you. This will have a value 1, 3, 8, 2 like this. This is nothing but value or data in the node. Now, this node has to connect to the next node. This head engine, nothing but this head. Uh, However, this will be our train, right? So this train engine should be connected to the next engine, next compartment. So that's why it should store where this address is. This address, let us take an example of this is at 011 and this is at 012, this is at 013, this is at 014. Now, this is storing the next pointer. Here it is next. What does the next store? This next store the memory address or the location where the next node is present. Where does the next node is present? At 012. For this 012, where does the next node present? 013. For this 013, where does the next node? 014. So write it like 014. Now for 014, where does the next node is? No. If there is no memory address for a node's next, that means it is the last node. That's why I said if if this is our if this is our last compartment, then we'll be having something like x pointer. X point is nothing but null. That's why instead of we will be storing just null pointer. Okay, thank you. Now it clear. Okay, I think it's clear. Okay, bro. Now let us go with solving the problem. Right? Okay. Linked list cycle. I'll get an error. However, let me tell you why and where I'll get an error first. Let us take A is equal to head. So I need to initialize a list node, right? So instead of node in Geeks for Geeks, it will be just node. But here, list node of A is equal to head. Now B is equal to head. Now, while A is not equal to null pointer and B is not equal to null pointer, if A is equal to B, return true. Now, A is equal to A next, B is equal to B next, next, and then return false at the end. List node A is equal to head, B is equal to head. No viable conversion from list node. A is equal to, okay, list node, I think it's how it will be. Let us see. No, list node A, no viable conversion from list node. Okay, list node A is equal to head. Okay, let us see what is the error here, right? It is saying that list node of, I got a head. Let us take it like this: list node of A is equal to head, and okay, that's what I do here, right? A is equal to head and list node of B is equal to head, right? Okay, we got a wrong answer. Head is equal to 1. Now, as I said, B will not be head. B will be head next. Head next. Okay, we got an error. It got accepted, but let me submit it. Let us see. I think you understood this, right? Okay, that's the error. If head is not there, right? If head is not there, let us see why does note that position is not passed as a parameter. There is a cycle in the list where the tail connects to the first node. Given head, the head of the linked list remains the link has a cycle in it. There is a cycle in linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, position is used to denote the index of the node that tail's next pointer is connected to. Okay, note that position is not passed as a parameter. Okay, I think we doesn't even need this position. Let us see. First, if there is no head itself, return. I think what we need to return here, I don't know. There is no linked list itself. What do they want to return? Let us return true. There will be no. I think uh, there will be no linked list. So no cycle also. So let me submit it. Yes, there is this runtime error 1 comma 2, right? Let us debug this. So debugging is most important when we are solving this uh, problems, lead code problems. So they have said that we have 1, this is our head, and we have 2, this is just the tail. The next pointer is pointing to this node. I am saying that A is at head and B is at head next. What is head? This itself. So this is A. Now B is head next. So this will be our B. There is no error till here. But let us go with this. While A is not equal to null pointer, B is not equal to null pointer. If A is equal to B, return true. Is A and B equal? No. A is equal to A next. Let us do that. A is equal to A next. That means A came here. Okay, A came here, but what about B? B is equal to B next of next. Here comes the twist. Let me tell you, wait a second. Let me tell you that as I said, the next pointer of this B is nothing but null pointer, right? The next of B, the next, excuse me, the next of B for any tail of a linked list, the next of that tail is null pointer. I said that null pointer is nothing but there will be no node itself. Node itself is not there, then we'll be saying that it is a null pointer. Now, what I said here, B is equal to this B is equal to B next of next. Like even there is no node, right? Now we want to access a node or a memory address for something which even doesn't have a memory address. So we are asking for a next for what? A null pointer, nothing but which is there, which is like it is like let me tell you, it is like a blank desert and you are asking for a cold coffee there. So it is something like a thing, right? So even there is nothing like a null pointer, no node. Now we are asking to get that next of that null pointer. No, it is not possible, right? Okay. How can we how can we uh, stop from this? Let me tell you. To stop this, I will definitely not change it. Why? Because B should go to B next of next. There will be a point like 1 and then 2 and then 3, right? Let us suppose that this is our linked list A and then B. This B can go to B is equal to B next of next, right? Now B can go to B next is this. Of next is null pointer. That's it. So if B next is itself null pointer, if B next is itself null pointer, then this will be false. If B is null pointer, what if this is A and head next is B? B is equal to null pointer. Now I want to access B as B next of next, which is even dumbest thing. So what I'll do is I'll just place only if B next is not equal to null pointer. Let me run this first using the test case, right? Let me know in the live chat, have you understood this or not? Let me submit it. Yes. Now what is the time complexity we are using here? Right. Do we iterating through the linked list more than one time? No. If I think n is the size, then it will take like big O of n time complexity, right? B is not equal to null pointer and B next is also not equal to null pointer. Then if A is equal to B, return row, A is equal to A next, B is equal to B next of next. So if you have any doubts, let me know in the live chat, right? So this is what question, let me tell you. Let me write it over here. Linked list cycle. Yes. Linked list cycle. Okay. This is the question linked list cycle. So if you have any doubts about this linked list or this problem 141, okay, let me know in the chat box. Do you have any uh, discussion if you want to discuss about this problem, right? So yes, we'll be starting this in 2 minutes. I'm just taking a small break. Yes, we'll be starting this in just 2 minutes. We'll be resuming it, right? 141. Problem number 141 in linked in lead code. Okay. Problem number 141 in linked list, lead code, linked list cycle. So let me know in the chat box whether you have any doubts or should I have to continue with our problem solving. 141 linked list cycle. One 41 linked list cycle, right? Okay, it's 8:45. So let's go with the next problem. We have successfully solved the first problem. Let us now go with the second problem. Middle of the linked list. Okay, this is the important and also mostly asked problem in what do you say, in interviews, right? So let us see that. First, let us address what is the problem, right? That's very important. Middle of the linked list. Middle of 876, 876, middle of the linked list, right? Okay, okay, middle of the linked list. So what are your thoughts on this? Given the head of a singly linked list, written the middle node of the linked list. If there are two middle nodes, return the second middle node. Okay. Okay, this is quite like I'm thinking about it. If there are two middle nodes, return the second middle node. Okay, let us see what does that mean. 1, 2, 3, 4, 5. Let me take the example, but before that, let me make it bold. So let us take an example here. We are given with 1, 2, 3, 4, 5. 1, 2, 3, 4, and then 5. Now, it is so easy to solve this, but I'll be solving like no need of brute force, however. But even if I have to, let us say, what is about the brute force? Let me write the algorithm. Go, go with a temporary node pointer and get the size. Go half the size of the linked list and return the wait a second, the middle node of the list node is 3. Return the node. Okay, we need to return the node instead of wait a second, 4 5 6. Okay, 1 2 3 4 5 6. This is the brute force and it will be taking like big O of n here and we go of n by 2. So overall of we go of n plus we go of n by 2, right? But how can we optimize it? Optimized, optimized, right? First, let us take this example 1, 2, 3, 4, 5. 1, 2, 3, and then 4, and then 5. Let us see. First, what I will be saying you is if I am having 10, right? Let us see like that. Let it be 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10. Imagine, imagine I have steps like this. Now, there is my friend, another a friend of mine who climbs stairs fastly, right? Okay, one step I'll go to this one step. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One step, and then 2, and then 3, and then 4, and then 5. Okay, I went 5 steps. 6, 7, 8, 9, 10. But we don't do it like this, right? It is quite boring. Now, as I am slow with only one step, what my friend do is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What does they do is instead of going with only one step, they go with two steps, right? Skipping one step. Okay. So one step of me equal to two steps of my friend, of my brother, right? Now, one step is equal to two steps. Now, let me tell you, 10 steps by my bro is equal to 5 steps. N steps of my friend is equal to n by 2 steps. So, if I went n steps and however made a pointer go, I will go exactly n by 2 steps. Let me tell you how, right? So, I went one step and my bro went two steps. Now I went the second step, went two steps ahead. Then the third step, yes, 6 steps. Then fourth step, yes, 8 steps. Fifth step, yes, 10 steps. Now, the next pointer of this is null, right? There is no step ahead. No step ahead. If you see, there is no step ahead of for my brother, but there is steps for me, half steps exactly, right? So this one, my bro skipped one every time, but I didn't skip anything, right? That's why by skipping one, it will take him to 10 steps, right? 10 steps, n steps. And when he reached that n step, I will be at n by 2 step. That's why this is called slow and fast. This is called as slow and this is called as fast. How much slow is moving? Slow is equal to slow of next. How much is fast moving? Fast is equal to fast of next. They said there is another thing, right? If there are two middle nodes, return the middle one. Okay. 1, 2, 3, 4, 5. Let's take that. 1, 2, 3, 4, 5. Now, slow, fast, now slow, and then fast, and then slow, and then fast here, null pointer. Okay. It's clear that we'll be ending at this point. Okay. Now, 1, 2, 3, 4, 5, 6, right? 5, and then 6. First, slow, and then fast. Now slow and then fast. Now slow and then fast. Then slow There is no next pointer here, right? No next pointer, and then there will be nothing like next of next. Okay, how can we solve this actually? I went with uh, so when I am stopping at a point where fast is not equal to null pointer, then I need to return slow of next. That's it. That's the edge case I need to solve, right? Let me write the algorithm first. While fast is not equal to null pointer and also fast next is also not equal to null pointer, then what I'll do, slow is equal to slow next and fast is equal to fast of next. And then okay, then if fast is not equal to null pointer, then return slow of next. Let us see, I'll not do this, however I'll return slow at the end. So this is the algorithm I have written, right? Let us see, let's code this. First, list node, but there might be constants like the same thing. There might be number of nodes in the list range from 1 to 100. Okay, if it is 1, head next. Okay, let's see, let's list node slow is equal to head and fast is equal to head next. Now while this fast is not equal to null pointer and also fast next is not equal to null pointer, then slow is equal to slow of next. Fast is equal to fast of next. Then if fast is not equal to null pointer, then return slow of next, else return slow. Let me run the code. I think this is not needed actually. Yes, it is needed, right? Okay, got accepted. Let me submit it. Okay, if you see what how many times we are iterating, right? Only one time, but you might say that this one will go of n time complexity, but no. Why? Because it will go bigger of n by 2. So when the fast pointer moves to the end, there itself it is stopping, right? It is only going halfway with the slow pointer, right? It will take big of n by 2 complexity, complexity, which is much better than big of n by 2 plus big of n, right? So if you are having any doubts, please let me know in the live chat. We'll be resuming this session at 9 p.m. Just 3 minutes, right? I also have to take some break, right? Okay. Can we hit 825 subscribers before we end this session, live session, right? So if you have any doubts, let me know that. Okay. Please let me know if you have any doubts. Just 2 minutes left. Let me know in the live chat or chat box. Excuse me. Okay, let's start this. Okay, but the debug process. Yes, sir, understood. The debug process you explained is really good, but sir, I'm a beginner. I want to know, is there any way to understand the large explained questions and how to debug the question? Give the whole process. Sir, but sir, as I'm a beginner, I want to know there any way to understand the uh, large. Okay. So, I think if you are having a difficulty on large questions, right? So, what I suggest you is now what I am doing is going with the problem, and then examples, and then constants is much important, right? And then go with your this is what given in the problem itself. This will be given, however. Now we need to write what is our thought. Even you write it or you imagine in your brain, uh, it doesn't matter, but you need to get the intuition of how you solve it, right? Now you might be getting an like what topic I need to do, or what data structure you need to use, or what algorithm I need to apply. All these can be excelled or can be mastered only if you do more problems, right? It is something like if you have to predict that this is on binary search, you need to have uh, solved more than like 12 problems on that binary search. Then only you can understand and you can say that this problem is about this data structure and this algorithm. Okay, now you got the intuition. Now write the algorithm first. Like what I'll do is I'll write the code, because these are something like in the process with an example. Okay, let us take uh, this problem, right? Reverse entry. Yes, this we can get more errors in this. There is a chance. Okay, let us take this example. But let me tell you how it will go. Like first, I'll write the algorithm, whatever the language might be, or whatever the language might be. Write the algorithm first. I'll do this, I'll do that. No, nothing like in a technical way. The algorithm should not be in a technical way that start and then end. Nothing like that. But in your own words, write the algorithm. Now, after that, write a pseudocode for that. Pseudocode and put these examples for this pseudocode and do a dry run. If these example test cases are passed, then only go to the code. Now, when you are writing the pseudocode, you don't see for syntax, you don't see for any errors, semicolons and all. This is just a pseudocode. You just need to apply the examples of this pseudocode and do a dry run on that. Now, after that, after these test cases are passed, then go to the code, right? Now, what if it is not accepted? If it doesn't get accepted, then go to the pseudocode again and make changes, right? You need to rewrite the algorithm, rewrite the pseudocode, right? And then, even if possible, you need to go to the intuition. There might be a wrong intuition or wrong process. Uh, you might be going with, right? So there might be a problem that your logic is not right or not apt for the problem, right? So let's go with solving reverse linked list, right? Okay. Given the head of a singly linked list, reverse the linked list and return the reversed list. How can we solve this? There is a brute force, right? So if you have any doubts, let me know in the middle itself, right? Or okay, reverse linked list. Uh, uh, okay, reverse linked list. Thank you, Unami bro. You're welcome, bro. Like, you can ask me any doubts if you have. Reverse linked list. Let us see. Given the head, okay, given the head of a linked list or singly linked list, reverse the list and then return the reversed list. 5 4 3 2 1. We need to return it, and we need to return the linked list itself, right? Linked list, if you see, we need to return the linked list, not any array or something like that. How can we go with the brute force approach? This is something like easy one for a brute force. Let us write it. First, I'll go with the reverse linked list. So it is clear that 1, 2, 3, 4, 5. I need to change. 5 should be at this position, 4 should be at this position, 3 should be here, 2 should be here, and 1 should be here, and I need to return the reverse linked list. Now 1 and 2, 2 should be here and 1 should be here. That's it. Now if head is empty, okay, we need to return the empty linked list itself. Okay, the values can be okay. A linked list can be reversed either iteratively or recursively. Could you implement both? Let us see. Can we implement it iteratively or recursively? Any ideas about this? So we have also got through the constants. We might go with the intuition of iteration and also recursion. But let me know in the live chat, do we have any ideas of how can we solve this, right? Let me know, right? Let us take an example 1, 2, 3, 4, 5. Now, can we do it recursively or iteratively? Like, let us go with the recursion, but I think going with the recursion might feel confused, right? Recursion, we didn't have it solved it like that. I think we need to go with the iterative solution, right? Iterative solution. Let's discuss this. So what I think is, what if I store, okay, 1 and 2, right? Okay, I need to just change the links like this. 2 and then this is 3 and then this is 4. This link is changed 5. I need to return this 5, this as my head. How can I do it? I have 1 2 3 4 5. 1 2 3 4 and then 5, right? Now let me take previous as the null pointer, right? This will be going with the null pointer at the end. That's the tail. I'll be changing it to tail. Now let us say this is our temporary node. Now if temp is not equal to null pointer, we'll go to the end, right? Now I need to change this pointer pointing to this, and I need to, if I did that, let us say I did it. I did one, next pointer is pointed to previous. Now what about this? I don't know where it is present. I don't know. I truly don't know where does it present, right? Am I right? There is no link with this temp and this too. If I go with temp of next, I'll go to previous. And previous is nothing but null pointer, right? So before changing the link, the temp next should be next node, should be stored in next node. Now what I'll do, I'll just change the link to the temp of next is changed to the previous. Now previous will be changed to the temp, and not and the temp will be, wait a second, temp will be our next node. Okay, this process continues. The temp is here. Now what will be the next node? Temp next will be the next node. Now temp next is equal to previous, and previous is equal to temp, and temp is equal to next node. Now temp of next is equal to next node, so temp of next is equal to next node, and this will be changed, and temp of next, sorry, next node is equal to temp of next, and temp of next is equal to previous. Now previous is equal to temp, and temp is equal to next node. The same process repeated again. Next node is equal to temp of next, and temp of next is changed to temp of next is equal to previous. Then previous is changed to temp, and temp is changed to next node. And if you see here, it is pointing to null pointer. Okay, now next node is nothing but temp of next, and temp of next is equal to previous. Temp next is equal to previous. Now previous is equal to temp, and temp is equal to at null pointer. As soon as our temp goes to null pointer, we stop there itself. Where did I start? I started with I started with previous is equal to null pointer, and I am just writing a pseudocode here. Let me write a pseudocode. But before that, what is the algorithm? Right? The algorithm is simple. Algorithm is initialize previous temp and while loop for temp and change like this. I'll tell you how. This is our temp is connected to this. Now this is our next node, and then this is our previous, right? So then what I'll do, I just change it to previous here, and then this is our temp and this is our next node. Uh, then then previous will be here and the temp will be here, and what about the next node? Next node will be here. The same thing. This is the algorithm. I'm just writing it in a diagram, right? Now previous is equal to null pointer, and what about temp? Temp is equal to head, while temp is not equal to null pointer, right? So if you have any doubts, let me know. Okay, now it's clear. Thank you. Okay, no. So if you have any doubts, let me know in the live chat. So if temp is equal to null pointer, I'll just create next node is equal to temp of next. Then temp of next is equal to what I did here. Temp of next is changed to previous. Then previous is equal to temp. So previous is changed to temp and temp changed to next node. That's what it did here. Previous is equal to temp and temp is equal to next node, and at the last, where did I get this 5? I got it at previous, so return previous. So we can solve this iteratively. However, I'll explain you the recursive one when I explain the recursion, right? Okay, let us start coding. List node of previous list node of previous is equal to null pointer. Then list node of temp is equal to head, while temp is not equal to null pointer. Then same list node of next node is equal to temp next. Now temp of next is equal to previous, then previous is equal to temp, then temp is equal to next node, then return previous. Let me run the code. Yes, it got accepted. Let me submit it. Yes, what is the time that we are using here? If you see, I'm just running the code for the loop only for one time. So the worst case I can go is big O of n. Big O of n. Time complexity is big O of n. What about the space complexity? Are we using extra space? No. So it will be big O of 1 itself. So I think you are clear with this. Let us see. I said after class, if I have any doubt how to connect you to resolve problems. Okay, I am giving you my LinkedIn profile, linkedin.com/in/rsai sidhu. So you can connect me there. So let me give you the profile itself. www.linkedin.com/in/rsai slash n, then r psi Sidhu. Okay, it's okay. Yes, I'll give you this again. www.linkedin.com slash in slash r psi Sidhu. Okay, you can connect me there. You can send a connection request. I'll be accepting it. However, merge to sorted list. I hope you all solve the practice problems which I gave you so that we can easily solve 200, more than 200 problems as we go out of this. Linked list is something like a data structure. Most of the people hate it, like solving it all, anything, but they hate it of solving this linked list. Even the harder ones, trees and the tries, DP, graphs, they can solve it, but this linked list is something like they can't. Not because it is hard, but because it is like we don't we are not we everyone who knows the linked list don't want to solve these problems. It feels like not to solve. That's it. Merge two sorted lists. You are given the heads of two sorted list 1 and list 2. Merge two sorted lists into one sorted list. The list should be made by splicing together nodes of the first two lists. Splicing. Okay. Okay. I think you got it. However, it is asking us like 1, 2, and then 4. Now 1, and then 3, and then 4. No, sorry. 1, and then 1, and then 2, and then 3, and then 4, and then 4. Okay. 1, 2. Okay. If I have to go with the two pointers, I've already said you about the two pointers. It is like P1, it is like P2. Now I have a P1 is lesser than or equal to lesser than okay, wait a second. Okay, let us create a dummy which is nothing but -1. Dummy next is equal to 1, and then let us go with the next one. It is lesser than or equal to, so I am going to P1. Now if P2 is lesser than P1, then create here and P2 will be incremented. Now P1 is lesser, so create a linked list and increment P1. Now P2 is least lesser, so P2 is incremented. Now I have 4. Is P1 lesser than or equal to P2? So 4 will be created and P1 went to null pointer. Then again P2, we need to go with all the pointers in P2. So go with all the pointers in P2. Sorry, create a 4 and then null pointer, however. So I will be returning dummy next. So what will be the algorithm for this? Let us create dummy is equal to new list node of -1. Okay, dummy is equal to new list node of -1. Now after this dummy I can go to these pointers, but let me tell you, P1 will be at head of linked list 1. Let us see how it is given. List 1. Okay, P1 is equal to list 1. P2 is equal to list 2. Okay, P1 is at list 1 and P2 is at list 2. Now while P1 is not equal to null pointer, and also p2 is not equal to null pointer. What I'll do, what I'll do is, if p1 of value, right? p1 value is less than or equal to p2 value, then then just create like, let us take this temp is equal to dummy of next. Let us start with temp is equal to dummy, right? So temp next is equal to new list node of p1 value. Else what I need to do, else I'll just that means p2 value is greater. So temp next is equal to new list node of p2 value. What is the least one? p1 here and then p2 here. Now temp is equal to temp next. Now there might be some of the nodes which are missing, right? So for that, temp is equal to temp next. Okay. Now while p1 is not equal to null pointer, what we will do is temp next is equal to p1 new list node of p1 value. Temp is equal to temp next. Now while p2 is not equal to null pointer, then temp next is equal to new list node of p2 value. Temp is equal to temp next. And the last, return dummy of next. Let us start this. First, dummy is equal to new list node of -1. Is equal to new list node of -1. Then list node of temp is equal to dummy. Now list node of p1 is equal to list 1, then here 2, while p1 is not equal to null pointer and p2 is also equal to null pointer. If p1 wait, p1 value is less than or equal to p2 value, then temp next is equal to new list node of p1 value. Else temp next is equal to new list node of p2 value. Then temp is equal to temp next. Now while p1 is not equal to null pointer, then temp next is equal to new list node of p1 value. Then temp is equal to temp next. Now while p2 is not equal to null pointer, then the same thing, temp next is equal to new list node of p2 value. Temp is equal to temp. Next, at the last, return dummy. Next, it might give me LTLE. Okay, temp. Next, so p1 is equal to p1 of next here, then change to here also p1 is equal to p1 of next. Okay, yes, let me submit it. And this linked list is so easy topic in data structures and algorithms. It just look, if you see, I'm just going through. Let us take n and m as the sizes, right? N, and let's just imagine that it doesn't have uh, any lesser value, greater values, right? Okay, something like 1 and then 1 and then 1, like this, and then here 2, 3 and then 4. So I need to iterate this and then iterate this. So big O of n plus m, big O of n plus m. This is the time complexity. What about the space complexity? It is just big O of n plus m. Why? Because we are creating a new linked list. So this is how you solve this, and we'll be ending this session here itself. If you have any doubts, let me know in the live chat. And also you can connect me in LinkedIn at linkedin.com/in/rsicitu. I have given the link in the message. And if you like this explanation, please like the video and then share to friends and subscribe to my channel. And yes, that's it.